present value. Otherwise, I want to write future value. I'm going to do the same thing here. This time, I'm going to reverse the roles. Oh, see, I didn't worry about this is in 12. This should be also in 12. I'm going to make a calculation here. First, I'm going to start from present, go to future. Whatever that present value is, times 1 plus my period interest rate raised to the power number of periods. Of course, there's a 0 there. Now, here's also what I'm going to do. I'm going to do a formatting here. Actually, I need to do conditional formatting here. This is a facility where you change the format of a cell depending upon something. So under Home tab, conditional formatting, I'm going to say new rule. And this rule will say, use the formula to determine which cells to format. Well, the formula is this. If that is true, I mean, I haven't put a tag to it, but I will be giving the present value as cash. So I want to fill that cell. I just happen to remember the hex code for that. Okay. And let's write down what this is. In fact, I'm going to share this here. Present. Actually, this present value as cash. For now, I'm going to leave it like that. So $1,000. And I'm going to make that into a little dollar format. And as you know, okay, and I'm going to well, this will always be red. So let's not worry about that. It is based on a formula. So right now, if I tell you, if you borrow $1,000 and you make no payments on your credit card, charges you 18%. 20 years from now, you're gonna owe 35,000 and some change. 18 is a lot of money. How about it's 4? Only less than double. In fact, there's kind of a shortcut. It's called Rule of 72. If you wanted to know how long approximately it would take you to double your money, take 72 divided by the annual percentage interest rate without converting the decimal. So at 4%, in order to double 72 over 4, 9. Okay, I think. No, 18. I'm sorry. It's not an exact number, and the approximation is better when the interest rate is small. Let's see. But now, here's what I want to do. I want that cell to calculate either future value if I give you present value, or present value if I give you future value. So that cell, that green cell, in fact, I need to change the formatting on that for now. Actually, I'm going to make it something else. Let me see. Uh, Conditional formatting. I'm going to manage rule, edit rule. Actually, let's leave it as green. I'm going to add a rule. If this cell equals false, or as the Germans would say, falsch, let's make it something like a turquoise, which is the color of Mediterranean Sea. I'm sure Jose knows about that. It is the most beautiful color you can get anywhere. See, it changes. I use that kind of trick when we do investment criteria. One of the things we calculate is the payback period. To find that, you need to figure out in what years you turn to positive. If you enter the cash flows, calculate the rolling cash flows, you don't even have to look. The year in which you go to positive, that cell changes color using conditional formatting. But now I'm giving you the future value. I want present value. Well, we know how to do that. Let's put an if statement here. Actually, I know we have a few minutes. If this thing is true, calculate future from present. And let's copy this, comma, calculate present from future. As we know, instead of multiplying with that factor, we divide by it. Now you have a nice little template that calculates you present value given future value, or vice versa. You didn't have to do two different templates. Okay? You can even do something special. I'm just gonna kind of show you this, get you excited about it. We'll build on that next time. Suppose I wanted to ask the question, how long it would take me to double my money at 4% exactly. Okay. Well, I'm gonna go from present to future. So here's what I want. I do under data tab, what if analysis, goal seek. I want my future value to be 2000. You enter a number there by changing length of time. Thank you. Yes, we have a formula to calculate that, but sometimes that is not possible. For example, you're going to see on Wednesday there's something called annuity, uh, a string of equal payments. If I ask you what is the required rate of return, there is no exact formula for that. Or how long it would take you to pay it off if you wanted to pay a certain amount, there is no exact formula for that. but that doesn't mean we can't solve it numerically. There is an Excel function that calculates that, but in more complicated scenarios, there isn't. For example, we use something called growing annuity for more advanced annuity applications, where you build in arrays to what's annuity pays every year. Well, in that scenario, Excel doesn't have a function. But if you can calculate the present value of a growing annuity or future value, all you have to do is do something like goal seek. Done. In fact, I'm going to show you how to kind of make that automatic. You don't even have to do the goal seek yourself. As soon as one of the inputs change, Excel is going to go ahead and run the goal seek itself. All right. So on Wednesday, we're going to continue with this, but we're going to extend this template into annuities. These are, mortgage payments, loan payments, and we're going to use that to solve retirement planning problems. I'm going to tell you exactly what I need in my retirement. I want $5,000 a month for 30 years. I want $5 million in my accounts at the end of those 30 years. I can save for 40 years. I can earn 8% while saving, 3% while in retirement. How much per month I need to save? You can calculate that algebraically. It's not that complicated, but it'll take a page and a half of algebra. And we're going to ask you to do that in 2 clicks by being careful about our templates. Templates, in fact, I call them abacus. Okay, in my setup, I have a collection of abaci. They're calculators. Okay, so what's the difference between calculating the logarithm of something using a calculator or square root of something versus loan payment? Nothing. Conceptually, you're solving a problem. When you're calculating a square root, you're finding a number such that when you multiply it by itself, it gives a certain number. You're actually solving an equation. It's a simple equation. In a lot of cases, there's not an algebraic formula to do it. What's the square root of 3? Who knows? It's an irrational number anyway. 1.73 something. By the way, here's a little info. Square roots of all prime numbers are irrational. Euclid has a little bit more lengthy proof of that too. All prime numbers, not just some. All right. I'll see you guys Wednesday. I'll have the lecture video posted sometime early tomorrow morning, including this Excel sheet and notes. Thank you.